The focus of this lesson is on dividing two rational functions, and so we're going to go ahead and take a look at taking f divided by g, which is just f of x divided by g of x. So my f of x is x squared over x plus 1, and then I'm to divide that by g of x, which is 2x over x squared minus 1. But whenever you're dividing two rational expressions or fractions, you multiply by the reciprocal of the second rational expression. So the reciprocal would be x squared minus 1 over 2x. And then from there, because it is a multiplication problem, it's beneficial that we're able to factor. So if we need to factor either numerator or denominator. And we can see in our second rational expression we have a difference of squares in the numerator, so we can factor that out. X times x gives us the x squared, and then positive 1 times negative 1 gives us the negative 1, and then outside inside adds up to 0x. And so that's the factorization. And then from there, whenever you're multiplying, you're allowed to cancel those common factors. And so we can see that this factor of x cancels with one of these factors of x and brings it down to a power of 1. This x plus 1 cancels out this factor of x plus 1. And as far as canceling goes, that's all we have. So what we're left with is we have x times x minus 1 over 2. And so that is our f divided by g of x. As far as determining the domain of f divided by g, we would look at f and see what would its domain be. G, what is its domain? And then we'd have to consider, is there any x's for which g of x is 0? If so, we have to exclude those x's. And then putting this all together, we'll also look at the intersection of f and g, and that will give us our domain of f divided by g. Those would be equal, whatever we get. And so from f we can see that x is not allowed to be negative 1. From g we can see x can't be negative 1, but it also can't be positive 1. And then as far as when is our function g of x going to be 0, because when g of x is 0, that means we're going to have division by 0. And we can see that means x is not allowed to be 0, because that's when g of x is 0. And so if we put all of this together, we intersect all these ideas together, we see that we are not allowed to be negative 1, 1, or 0. And so our domain starts off at negative infinity, and then it comes to negative 1, and then there's a break, so we union from negative 1 to 0, and then there's another break, so we union from 0 to 1, and then there's another break, and then union 1 to infinity. So if you've got 3 breaks, which we do, then you're going to have 4 pieces in your domain. So our domain is everything but negative 1, 0, and 1 is what that says.